in 11.5, we are going to focus on geometric sequences. Back in 5.5, if you have your binders with you and you have your notes with you, we talked about arithmetic sequences. Arithmetic sequences are just where you add the same number to get to the next. Remember that this could look like a subtraction where you're adding a negative. So an arithmetic sequence would be something like 2, 4, 6, 8, 10, 12. You're adding 2 each time. It could look like 100, 95, 90, 85, 80, 75, 70. You are adding -5, or you're subtracting 5, but you're adding -5 is your common difference. If you remember that phrase, common difference, what you're adding or subtracting each time. Now we're going to look at geometric sequences, which is where you're multiplying the same number to get to the next. Okay, so you're going to times it by 2 and times it by 2 and times it by 2 and times it by 2 each time, or times it by 7 and times it by 7 and times it by 7 and times it by 7 each time. This can look like division, where we have multiplying a fraction. So maybe it looks like we're dividing by 2, but we want to say that that is timesing by 1/2. Okay, so we don't want to ever say that we're dividing by whatever. We want to say we're timesing by whatever the fraction is. Our number that we are multiplying by each time is called our common ratio. So back up here, we said this is the common difference. Because in these ones, what's the difference? How we changing? We're changing by the same amount each time. We're adding each time. Common ratio. Fractions are ratios. So how is it that we're multiplying each time? What is the ratio from the first term to the second term to the third term? Okay, so common ratio, what's the number they have in common that we're multiplying by each time? Your common ratios can be positives or negatives. You can multiply by 2, or you can multiply each number by -2. They can be fractions or they can be decimals. So we like to use fractions a lot of times, but sometimes we'll see decimals, and that's fine. I believe your IXLs that you're going to practice are accepting decimals. I believe. If I'm wrong on that, I'm sorry. But just stick with fractions. If your sequence has decimals in it, then absolutely use decimals. But if it has just whole numbers and maybe fractions, I would stick with fractions. Just better, they're easier to work with. Okay, so we're going to look at a couple of examples, and you're going to hopefully be able to tell me if these are arithmetic, geometric, or if it's neither, because there's lots of sequences that are neither. Okay, so arithmetic is add, geometric is multiply, and neither is neither of those things. Remember though, with arithmetic and geometric, they have to add or multiply the same thing each time. So not just that you can find a way to add something to get to the next number or multiply something to get the next number, it has to continue to be that pattern every single time. So when we look at our first one, we've got 5, 7, 9, 11. So when you look at that, this one is probably, hopefully, pretty easy. You can look at this and say +2, +2, +2, which makes that one arithmetic. I'm just going to put an A for arithmetic because you're adding 2 each time. Okay. If we look at the next one, 2, 4, 8, 16, you may initially look at this and say, oh, 2 + 2 is 4, it's arithmetic. But look again, 4 + 2 is not 8. So this cannot be arithmetic because it's not adding 2 each time. So then go back and see, well, maybe it's geometric. Well, 2 times 2 is 4. I'll continue on. 4 times 2 is 8. 8 times 2 is 16. So this is geometric, and you are multiplying by 2 each time. Okay. If you look at your next one, you've got 3, 0, -3, -6, so on and so forth. So if you look at this, it starts with 3 minus 3 is 0, and minus 3 gives you -3, and minus 3 again gives you -6. So this is arithmetic. Your common difference is -3. It looks like we are subtracting. If you go to the next one, we've got 7, -8, 9, -10, so on and so forth. Now, if you look at this, it looks initially like adding because 7, 8, 9, 10, but when you look closer, it's positive, then -8, and then positive, and then -10. So that's not arithmetic because 7 plus 1 gives you +8, but we need -8. And there's not going to be a way to make this adding the same number to make this arithmetic. And it's definitely not geometric. What number, 7 times what gives you -8? That's not going to work. So this is a case of that, neither. Next one, we've got 9, 3, 1, 1/3. From 9 to 3, you might have said, well, -6, but hopefully you saw very, very quickly that that does not work out. If you have a fraction in your problem, but not every single number is a fraction, it's probably not arithmetic. It's not that it can't be, it's possible, but I would lean towards the geometric or the neither. So when we look again, we've got 9 to get to 3. Well, we can do 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is, well, 1 divided by 3. It literally says 1/3 right there, 1 divided by 3. So this is geometric. So in this case, when we have where we're dividing by 3, we would say our common ratio is 1/3. Okay, so your common ratio is 1/3 in that problem. Oops. Next one, we've got 4, 5, 7, 10. So when you look at that, 4 plus 1 is 5, but 5 plus 1 is not 7. So it's not arithmetic, not geometric. 4, 5, 7, 10, that's not, nothing works there. That is a neither. You may have seen that this is 4 plus 1 is 5. 5 plus 2 is 7. 7 plus 3 is 10. But this is not, this is a sequence. I could predict the next number. I should be adding 4, which means my next number would be 14. But that's not arithmetic because you're not adding the same thing each time. Okay? Now we're going to get into some of our formula stuff that we've talked about back in 5.5 that will extend into our geometric. So just recall that we use this a little n, a sub n, to represent a term. And a sub n minus 1 is just the term before that. So when I've got 1, 2, 4, 8, 16, when I say A3, that means I'm looking at the third term. This is the first, second, third term. A3 is 4. So an minus 1 would mean the term before that, which would be 2. Okay? We're going to use these in our recursive formulas, where the an is kind of like y, and the an minus 1 is kind of like x. So this is your input and this is your output. So recursive formulas are actually pretty easy because all you're doing is they're telling you how to get to the next term. Where you're going to use an is y and an minus 1 is x. So to get to the next term, you use the 1 before it. And then how does it change? So these are examples of recursive formulas. This one right here is saying I take a number, I add 3, it gets me to the next number. This one is saying I take a number, I times it by 2, and I get to the next number. A way to rewrite this is kind of just like y equals x plus 3. And this is kind of like y equals 2x. So you take the number you know, you times it by 2, you get the next number in the sequence. You take the number you know, you add 3 to get the next number in the sequence. So we're going to write the recursive formulas for the following. And along the way, I'm going to help you, I'm going to show you how you can find the common difference or the common ratio if you're ever unsure. Okay? At some point during this video, I am probably going to get cut off. I only have about 15 minutes to record videos. I'll do my best to make it a nice cutoff point before we start the next video, but I'll do my best. All right, so first thing you need to do when you're writing your recursive formulas is just know what is happening in your sequence. So your recursive formula is always going to be AN equals. So then you're going to look to see what is happening in this sequence. 10, 7, 4, 1. Well, first of all, you notice it's going down. You want to notice it is going down by 3 each time. I'm subtracting 3 each time. So that means I'm taking the number that I know and I'm subtracting 3 each time. And that's your recursive formula. You always should have AN equals, and then AN minus 1 should be on the right side, and then just tell me what happens to it. How do you get to the next number? On your next one, I have 3.5, 5, 6.5, 8. So maybe you're not 100% sure what's happening. First, you should notice it is at least growing. If you don't know if it is arithmetic or if it's geometric, you have no clue, no idea. My recommendation is start with arithmetic. It's the easier one. In all cases, you take a number farther along in the sequence and then subtract the number before it, if we're looking at arithmetic. So I'm going to take 5 and I'm going to subtract 3.5. And when I do that, I get 1.5. If this is an arithmetic sequence, this is my common difference. 3.5 plus 1.5 gives me 5. So now check 5 plus 1.5 to see, yes, it gives you 6.5. And then 6.5 plus 1.5, yes, it gives you 8. So this is your common difference for your arithmetic sequence, which means your recursive formula would be AN equals AN minus 1 plus 1.5. Because you're adding 1.5 to get to the next term. All right, in our next one, 1, 2, 4, 8. So we know we're going to have AN equals what's happening to get to the next number. So 1 plus 1 is 2, but 2 plus 1 is not 4. 1 times 2 is 2, times 2 is 4, times 2 is 8. So I'm taking 2 times the number that I know. Okay. This is one that you probably don't know initially just looking at it. We might not even know if it's arithmetic or geometric. Now, here is one little trick or little tip. If there's a fraction at some point along the way, it's probably geometric. Most likely. So let's go with that route. So just like we did back up here, you're going to take the one farther into the sequence, and this time instead of minus, we're going to divide by our one before. Now, arithmetic, if you think about this, arithmetic should be adding each time. So the reason we subtracted is because we went backwards. So geometric is supposed to be multiplying to get to the next one. So if we're going to start with 12 and we're going to go backwards, we need to divide by the number before it to see what our common difference is. So I'm going to use Desmos to do that. Now, remember I said I don't want decimals, I want fractions, so I'm just going to fraction button it and 3 over 4. So now I'm going to see if this is my common ratio. So I'm going to start with 16 times 3 over 4. Gives me 12. Then I'm going to do 12 times 3 over 4. Gives me 9 like I wanted. And then I'm going to take 9 times 3 over 4. It gives me 6.75. What is that? I don't know. Let's see. 27 over 4. 27 over 4. So this is your common ratio. So your sequence formula is AN equals 3/4 times AN minus 1.